Welcome back. We're continuing to shadow the development of CRVFunder. And in this case, we're going to do a deeper dive into how it's setting up its testing suite from the outset. As a reminder, the CRVFunder project is being used to direct emissions, not to Curve pools, but to projects that might be interested in receiving Curve rewards. So, for example, the DAO could vote to fund Viper development or Brownie development. The project at this stage, and all these are going to be checked in the repository, is still in its infancy, but it's very useful to see the framework on which the tests are being set up, because the tests feed in very directly into the development of this project. So as always, we have a conftest.py. And one of the interesting ways that this is being set up is by importing some various PYTEST plugins. These are files that we're storing in the fixtures directory within tests, one for accounts, one for deployments. We'll look at them in a second. These are going to be automatically loaded, and these are pretty useful, and you might want to snip these and copy at least the accounts one for use in your project, because it's used very frequently. First, just walking through the initial commit for the conf test, we have two different tests that are in here. This first one's a pretty interesting use case where if you haven't written any tests yet, you don't want to prevent yourself from committing. We saw how you can use GitHub hooks in the last one to tie into your entire development environment, make sure that tests pass. If there's no test passing, it's going to trigger an error. So in this case, this is a fixture level conf test that we're creating, which once the session is finished, if the exit status is that there was no tests, we don't want that to be triggering an error. So we simply set the session exit status to pytest.exitcode.ok. Take a look at the PyTest documentation for all the details, or just clip this line of code if your project is new. And then, as always, we have the PyTest fixture, which is automatically used, called isolation. This is going to run every time and reset the chain state. Taking a look at these two different fixtures, the first one is very simple, but you've probably seen Alice, Bob, Charlie, account 0, account 1, account 2. We use these all the time because it's easier to type, and Alice and Bob are easier to visualize. So this is simply a fixture that's loaded that's going to return Alice, Bob, Charlie. Nothing terribly difficult here. Note that the scope is session. We talked in some previous lessons about how the session scope is the highest priority one, because this is the one that's done once, executed first, and then doesn't change for the entire session, followed by module and then lower level scopes. And then at the module level, we have the other one, which is our deployments. Now, this one's really interesting, especially given that we're building off of Curve. We've done a lot of our testing on the Curve forked mainnet, but if you'd like to have the basic Curve contracts deployed to a development environment, you can do it using all these deployments here. This is going to deploy basically the skeleton of all the important Curve contracts to your local gauge. So for example, we have the Curve DAO. In this case, this is utilizing the Brownie package manager. Brownie package manager is an easy way to take libraries and run them directly through Brownie. So in this case, this is loading the Brownie package of CRVFI/Curve DAO contracts at release 1.3.0, and it's going to return a fully functioning Curve DAO whenever you call this. The Curve 20 is going into this Curve DAO package and pulling out the ERC20 for Curve and deploying a working Curve DAO token. It then sleeps for enough time for missions to start, and finally it updates mining parameters. These are the very basic initialization routines needed to set to actually have a working copy of the CRV20 token. For VE curve, we have a dummy VE curve returned. Similarly, further modules return a gauge controller, a minter, and a factory. Finally, the CRVFunder local contract here on line 40 is the actual local implementation of the project that's being built. So this one would be unique to this project, but you would generally going to have some sort of local contract you're developing and deploying. Similarly, an implementation and a funder is releasing a couple of permutations on this CRVFunder local contract. So this is how an actual test suite gets structured. It's much more nicely organized than just including everything in your conf test file. And as you look at the tests, you can take a sneak peek at the very first test. It's in the repository. We're not walking through it, but you can see that we're already up and running in terms of getting this project utilizing tests and making sure that our contract that we're building out is working as intended. We're going to have more updates coming up in this series, but great snapshot into how you can look through structuring your project to make sure it's ready for the application level.